So like I said, part 2, we're going to go ahead and learn how to multiply and divide. Before we do that though, let's go ahead and review a little bit from yesterday. So yesterday we had some problems like this, and maybe we could try number 8 real quick. Make sure you can still do this. Don't forget, when you have negatives, you're going to need to distribute this negative. And so I often like to put a -1 out in front. Whoops, back that up. I just put a -1 right there. And then distribute this way, like this. So we get 3 plus 7i. And then -8. And then a negative times a negative is a positive, so you get plus 2i. And now we can add the i's together. We can add the real number parts together. So these two add together, and we get -5. Okay, can you guys not talk now? We're doing a math lesson, okay? Alright, now 7i and 2i gives us 9i. And remember, when we're writing things in standard form, we write the real part first and then the imaginary unit part. Keep them separated. So that's why we have this written this way. Okay, so let's just look briefly at an application problems, because you guys are probably wondering, where on earth would you ever use such a thing? Well, this type of problem actually comes up in circuits. When you have resistors, inductors, and capacitors, and you don't really need to know necessarily what each one of these does, but a resistor in a circuit, it's kind of like a heater. It's something that produces heat. Kind of like a heater. All those coils in a heater are basically a resistor. Inductors come up all the time. They have to do with magnetism. And we use inductors to make a switch, basically. Can kind of give you an idea of how that works, if you don't mind. Every car has, like, well, most cars have what's called a starter relay, and you have a coil that's wrapped around like this, and as electricity goes through this coil, it induces a magnetic field. So what happens is you have a little metal thing here that's attracted to magnetism. So when there's electricity going through, this switches over this way, bends this over this way to make a new circuit. And so what happens is then the electricity ends up going through this side over here, and then it goes through the starter. Like almost every car has a starter relay, and it involves a lot of amperage. So you don't normally want a lot of amperage going just for wasted energy. So it has a relay in here, and so inductors are used all the time to create a magnetic field. And anyhow, and then capacitors are another device that are used often in circuits, and it's basically acts like a little battery. It fills up with voltage here, and then it's kind of acts like a little battery. So often these things can act together in a circuit. And what we can do is we could calculate the total impedance. And the impedance has to do with the flow of electricity. Like, it kind of slows down the current. Think of a river moving. If you put some rocks in a river, it slows down the river, right? So the current can't go as fast. And you throw a bunch of logs in it, it will slow it down too, and just various things will actually slow down the water. And so the impedance has to do with the amount of resistance that you're getting in a circuit. Well, look at these numbers down here. You recognize that one? That's just resistance, R. Then we have this, that I there is the imaginary unit. That I that we've been talking about, it's equal to the square root of -1, right? The I that we're talking about here is equal to the square root of -1. And then there's another one right here. So that's Ci. It's whatever your capacitor value is, then you multiply it by I. And this is your inductor. And so you look up here for your inductor and stuff like that, and you can figure out, like, this produces 3 ohms of impedance, but that's across the inductor. And then this causes 5 ohms of impedance across the resistor. And then this one causes 4 ohms of resistance across the capacitor. But you can sum these up. And so here's an example in your book where it shows you this. I'm going to go one more. And so notice if we wanted to add up the total impedance, what we'd do is we'd take 5. That's where they got the 5. There's across the resistor. It's exactly 5. That's where they got that one. Okay. And then across the inductor, that's this guy right here. That's a magnetic coil. You're supposed to put an I thingy with it. So you end up with 3I right there. Okay. And then across the capacitor, that's this guy right here, we have 4 ohms. But we calculate the impedance as a negative number. So we just throw in a negative involved there. So what you can end up doing is finding the total impedance. And so we've been learning how to add and subtract these things. Well, here's an application problem where you're calculating the total impedance. So we'd write that as 5, and then 3I minus 4I, that's minus I. So it comes up, there's a simple little calculation we can do, and then this would be a little calculation that's used to do a more important calculation. And you'd have to go into a lot of electronic stuff before you get to those calculations. So it's just a basic idea, but the point is it comes up in electronic circuits. And as you study electrical engineering, this imaginary number comes up a lot. Anything electrical will have this imaginary number with it. And so when you take advanced calculus and things like that, you learn about this number quite a bit more. In any event, it may be that this would be the only application problems you're going to see involving that I thingy for now. But it will come up if you continue your studies. So the next thing we're going to do is multiply. And we use the FOIL method and things like that, distributive property, just as we've been doing in the past. And once again, to multiply and to divide, basically there's 2 ideas you need to know. I is equal to the square root of negative 1. And I squared is equal to negative 1. Okay? So these are the 2 facts we'll use when we're multiplying. So let's take a look here. If we distribute here, we get negative 6 times 4i. We'd say, well, that's negative 24i. And then we'll multiply this one times this one. We get plus 4i squared. However, we were just told that I squared is equal to negative 1. So this is the same thing as negative 24i plus 4 times negative 1. And so then that equals negative 24i minus 4. Now, is this written right? Well, that's kind of a trick question. When we're writing complex numbers, we're supposed to write them in standard form. And that means we write the real part first, and then we write the imaginary part. And you'll notice the imaginary part right now is written first. So technically speaking, this isn't written in standard form. We'd put this number first. So we write this as negative 4 minus 24i. And now it's written in standard form. Does that make sense? Okay, so what I want to do is I want to do this example, and then I'll let you do your study guide. You'll have a couple multiplication ones in your study guide. Okay? And then we'll learn about dividing. Okay, so for this one over here, we'll just use our normal FOIL method. 9 times negative 4, negative 36. 9 times 7, I think that's positive 63i. And then this one times this one. A negative times a negative is a positive, so this is positive 8i. And then finally we do last times last. Negative times a positive is a negative 14i squared. Now, the I squared, once again, it's that's going to be the same thing as a negative 1. So if you want to, you could just scribble that out and put a negative 1 there. Well, negative times a negative makes this a positive, so that would change that to a positive 14. And once it's a positive 14, then you can add it to this one over here. Does that make sense? So if you take negative 36 and you add 14, I think that gives us negative 22. And then you can combine these two together and it gives you what? Positive 71i. Now I like to write my i's with a little hook on the bottom. And the reason why I do that is I don't want it to be confusing with the 1 itself. Does that make sense? And I'll always make sure there's a little dot on top of your eyes. Alright, so anyhow, that's how you do multiplication. So on your study guide, if you look at your study guide, you should be able to do problems 6, 7, and 8. So take about 3 minutes and do 6, 7, and 8, would you? And I'll go ahead and stop this. I'll stop this for now. Let's go ahead and continue now. Now we're going to learn how to divide. So let's go back. Oh, I need to go to the PowerPoint. Okay, so okay, we're going to use the conjugate idea again, just like we did with square roots. I'll wait until you're done. Are you done? Okay, so keep in mind this is just like what we did with the square roots. And you're going to want to use the conjugates when you're dealing with complex numbers as well. Okay, so remember when we're dealing with square roots, we noticed the fact that a squared minus b squared is equal to a plus b and a minus b. Now this setup is kind of nice because when you do this and you multiply it all out, there is no middle term and you end up with a bunch of squares. Well, that's kind of nice because if we have an I squared, we're going to get rid of the I squared because it's equal to negative 1. And the middle terms, which would be like 5i, 5i plus 10i or whatever, these, you see, because one of these is plus and one of these minus, we won't have that because they're always going to subtract off because you always have the same thing. So you might have 7i minus 7i in the middle. So that gets rid of the I in the middle term. And then, of course, the a times the a is a real number times a real number. So this is a clever idea on how to get rid of the i's. And that's what we're going to want to do when we're dividing. We don't want i's in the denominator. Same thing with square roots. So this idea works with square roots. It works with imaginary numbers as well, or complex numbers. So let's go back here and find out. Okay, so here's the thing you should always remember. When you multiply complex conjugates, you get rid of the i's. You only have a real part left. And this is just a quick example to verify that. 2 times 2, of course, gives you the real part. 4. 2 times a negative 3i gives you minus 6i. The other inside product gives you plus 6i. And the final product of the FOIL method would be last times last. Gives you the minus 9i squared. Of course, these i's subtract off. And then the I squared is equal to negative 1, which changes this to a plus 9. And then you can just wipe out that I there. And then 9 plus 4 is 13. So you can see Whenever you take a number, a complex number, and multiply by its conjugate, you will always get rid of the I. Okay, so that being said, we can deal with quotients. So the other thing is that we're going to want to do is write things in standard form. So that's just going to involve one extra little bitty step. Remember, the standard form is like A plus or minus BI. It's going to look something like that. Well, so let's take a look at this problem. The conjugate, or the complex conjugate of this one would be, we're going to have to multiply. We're going to multiply by, how about 1 plus 4i? Okay? And you're going to have to do the same thing in the numerator. You have to multiply by the same conjugate, 1 plus 4i. Well, now that you guys are all good at multiplying, because that's what we were doing on the previous 3 problems, you should be able to do this pretty easily. So if we simplify the numerator, we'd have 7 times 1 to 7. 7 times 4, 28i. Okay, and then 5i times this one plus 5i, and then 5i times this one gives us plus 20i squared. Now in the denominator, we know we're going to get a different story because the middle terms subtract off. So 1 times 1 gives us the 1. 1 times the 4i is going to give you 4i. And after this example, I'm going to take shortcuts. I'm not even going to waste time multiplying the middle terms because I know they're going to subtract off. And this one gives us minus 4i. And then finally we get minus 16i squared. Okay, so now we just need to simplify things a little bit. Let's start off with this one over here. I squared is negative 1, so if we change that to negative 20 and then get rid of that, we can then combine it with this one. So that gives us negative 13. Okay, and then we can combine these two i's together. That gives us plus 33i. Now these i's subtract off, so they're gone. And this is negative 1. So that becomes a positive 16, and then that's gone. And 16 plus 1 is 17. Now a lot of people like to stop here, but this isn't written in standard form. Standard form looks like this: A plus or minus BI. In other words, you have to separate the real part and the imaginary part. So to do this is a neat little fraction trick. Since you have a denominator here, you can separate the two fractions. You can write this as negative 13 over 17 plus 33i over 17. Okay? So you can separate the two fractions because they have a common denominator. Okay? So that's going to be the final step, is to separate the two fractions. Okay, I think what I'll do is just one more of these, and then I'll let you complete your study guide. Let's do one more. Let's try, how about this one, number 13. Okay, so the complex conjugate of 1 plus i would be 1 minus i. So we're going to multiply by 1 minus I. Now hopefully you guys get that. 1 minus I here. And now we just need to multiply and see what happens. Whoop. Go that far up. So if we simplify the numerator, it would be 5 times 1 gives us 5. And 5 times negative I minus 5i. And then in the denominator, we're going to multiply the first times first, which gives us 1. And then I don't even care about the middle terms because they're going to subtract off, right? And you're going to get a negative I and then a positive I, and they subtract off. So let's move to the last times last. It's going to be minus I times I, which is I squared. Now then, I squared is really the same thing as negative 1. So if I think of this as a negative 1 here, okay, then a negative times a negative is actually a positive. So this actually becomes a plus 1, okay, and so you get 1 plus 1, which is 2 down here, okay, and so then you end up with 5 minus 5i. Now, the only problem with this setup right here is that it's not in standard form. So to write it in standard form, you just separate the two fractions with the common denominator here. So you get 5 halves minus 5 halves I. Okay? Well, now I think you're set to do problems 9, 10, and 11.
For 9?
Yeah.
You know how you just have I?
Yeah, the conjugate is going to be negative 2i.
Oh, 2i? Negative 2i?
Yeah. Yeah, so that one's a little bit different. Let's look at that one real quick and help you get started here. The conjugate on this one is just going to be this is so annoying. Alright, I'm going to get that pen going again. It's going to be minus 2i. Okay? So you're going to multiply the top also by minus 2i. Alright, that's the only hint I want to give you. See if you can finish up 9, 10, and 11. And then I think your study guide's done. So you'll turn in your study guide, and then you'll start the book assignment. You have about 20 minutes to get started on it, and you'll be ready to turn that in tomorrow. So tomorrow we'll start 1.7. And by the way, 1.7 will be one of the harder sections, so make sure you're here and pay attention to that. Out of the whole chapter, 1.7 I think is the hardest section. So, alright, I'm going to stop this.